Now, the assembly of the International Space Station is a task that has relied very heavily on the use of robotics, most notably the station's remote manipulator system, or Canadarm2. That was used to put entire modules into place, as well as to move astronauts and other equipment from place to place. But the fact that the assembly is almost over doesn't mean that the use for robotics is over. In fact, last week, robots were front and center on a task, a cargo transfer job that didn't require astronauts to suit up and go outside. We're going to take a few minutes today to talk about that recent work and the use of robotics on board the station. With me is Ian Mills, who is one of the robotics officers here in Mission Control. The task last week that I was mentioning was moving things called CTCs. Let me get you to start by telling us what a CTC is and why these needed to be moved.
Sure. Okay, the CTCs are a cargo transport container, effectively just a big metal box with a hinged lid. They contain orbital replacement units, ORUs, things that we can replace on orbit robotically or EVA crew.
But these are spare parts that are just stored out there.
That's correct. These particular CTCs contained the remote power controllers that we use. They're just switch boxes that we power on and off different loads. Why we were moving these particular boxes, we had, at the beginning of last week, we had one of these CTCs stored on board Dextre, as he is commonly referred to. We refer to him as the Special Purpose Dexterous Manipulator. Obviously, you can see where he gets his name. We had a CTC already on board the SPDM, and that was to support replacing a failed RPCM. However, that did not happen. There were certain thermal issues that were brought forward before those operations were able to take place. So we've just been holding this CTC effectively on our back as we have gone along with other operations. Time has come now to prepare for the next H2 transfer vehicle coming, HTV4, and the expectation is that we will not have any cargo on board the SPDM because it will be used as part of those operations. So the main goal for the task last week was to relocate the CTC that we had, we'll call that one CTC3, and put it in its expected location for the HTV4 mission.
And then in the process, freeing up a spot on the SPDM for other uses.
That's correct. For the transfers, the cargo transfer that's coming up on HTV4 will utilize the SPDM storage location. So we needed to clear that. Combined with that, the program had decided that it made more sense to put the CTC that was outboard, we'll call that one CTC5, put it in the place, move it closer to the crew airlock, and since there are orbital replacement units, the spares inside these boxes, putting that particular CTC closer to the U.S. airlock makes it more accessible to EVA crew if they have to go out and perform some kind of repair. So that was the main goal for the operations last week.
I mentioned Canadarm2. People are very familiar with that. It's very dramatic when you see it. You don't see the SPDM that much. Tell us what it does that the ARM can't. What makes it special? Okay,
well, you may not see it very often, but yeah, it's come to the forefront as far as robotic operations. What it does allows us to do that's different than we do with the Canadarm is it is a smaller robot that allows us to have finer control for doing the detailed task work that we need to do to effect repairs on the station. Its main purpose is to allow us to repair certain units that are robotically compatible without having to send EVA crew out, which frees up the crew members to continue with science on board. So that's the primary difference between the SPDM and the Canadarm.
If the RMS is an arm, is the SPDM a hand?
It's more. I would think of it more like it's an extension of. Yes, that's reasonable. So yeah, we use SPD or the SSRMS, which is a 56-foot long manipulator, and it was designed and built for space station assembly. It was designed also to be able to pick up the SPDM to do the fine work. So yeah, that's a fair analogy to call the SSRMS big, and the
smaller one.
The smaller one would be the hand for the dexterous work.
And in this particular case, all of these operations that went on didn't involve the crew at all. And by that, I don't mean just the crew didn't have to go outside to do work. They weren't involved in controlling the arm either. It was controlled from the ground, right?
That is correct. Since I want to say 2005, when we first started executing maneuvers of the Canadarm2, we call it SSRMS. It's an acronym name. We have to use those since we're NASA.
Yes.
Since we started ground control of SSRMS in 2005, we have progressively increased our capability. We started out with very small scripted maneuvers, and now we're to the point where, yes, we are engaged from the ground, solely from the ground, with fine ORE replacement tasks that can also be executed by the crew via EVA, but it does make a lot of sense for us to be able to do it from the ground.
When we say that you can move it from the ground, we don't mean just over here in this room, right? There are more than one place from which you can run the arm.
There are. We have we do have a console here in Mission Control where we sit. We also have a control center in Canada at Montreal, the Canadian Space Agency, where we do have operators that are trained and certified as well that do the same flight control job. We don't have them. We don't have the primary position there yet, but I know that is in work. So primarily, it's run out of here, and then the backroom support, if you want to call it that, is frequently manned by our trained personnel at CSA.
What is it like to sit here in this room and command a 50-foot-long robot that's in orbit? Is that fun?
It is fun. For me, it's exciting to sit here and be able to send the commands, yes, and have the arm move, go where you tell it to go, or complete an install of the CTC as we were talking about. For me, it's very exciting. There's a high degree of complexity to it. I know it's probably not very fun to watch because the rates that we operate with are very slow. So to make it interesting, we have to do a time-lapse playback so that you can actually perceive some of the motions, because that is one of the constraints that we operate with, is to maintain safety, is that we operate this in a very controlled, slow, deliberate manner, especially when we're in contact or engaging a mechanism.
Your CTC operations last week proved that there is always something that can go wrong. Explain what it was that happened. There were operations on 2 days, Thursday and Friday last week, and Thursday you were starting to move one of the CTCs. And what did you encounter?
Well, let me start by just saying that I have been here at NASA for 17 years. I've been in the robotics operations group that entire time. And one thing for sure that I have learned is that nothing ever goes exactly as you planned, and the issues that you encounter are not necessarily what you are prepared for. So what happened to us last week was the operation involved first picking up CTC 5 and bringing it around to the stowage platform close to the airlock. When we got over there and began to put it down, it got stuck. It would not go all the way down. And we, after a quick video survey, realized that there are some straps, some thermal straps coming off of the adjacent box to where we were putting this down that we did not account for in our models. Combined with the CTC itself actually has a handrail. We also did not have that handrail in our model. So it was the interference between these straps and this handrail that caused us to not be able to put the CTC down.
Wouldn't fit in the spot.
In that spot.
You got to stop and think about what you're going to do next. How do you resolve that situation? What was the answer here?
The answer ended up being the box, since it contains spares, they require thermal conditioning to maintain their survivability, their usability. And so a 10-hour thermal clock was started when we pulled the box off of its original location, and so we were working against that clock. And so it may have been possible for us to figure out how to work around these straps, wiggle our way down at this location. However, to me, I didn't feel like we had enough time. So what we ended up doing was standing down for an hour and a half or so, put together a plan to just backtrack the same trajectory that we came from.
Return it.
Return it back to its original location.
And yet you were ultimately able to achieve the other goal, and that was to free up that spot on the SPDM.
That's correct. Since both of these boxes that we're moving around were CTCs, and they are mounted on common attachment system that we call the FRAM, that's a flight releasable attachment mechanism, either can go in either spot. And we did stand down and evaluate the situation. Since we ran into our models being incorrect, we first needed to validate the CTC config. So we took some video on board just to verify what its config was. It did not have the handrails we expected, so there would not be the interference between the straps and that handrail. So we decided to just go ahead and put the CTC down where we were planning to put the CTC5. And I know that's a bunch of numbers and it gets all jumbled, but eventually we ended up in the same config. We had these two boxes in their same locations. They were just reversed from what we had intended.
And you found the solution and got into the configuration that you were after. A little ingenious thinking that actually won you a lot of praise at the mission management team meeting yesterday for creative thinking.
Yes, I won't necessarily take that all for myself. It is a team effort. We have 3 people that man the console for the robotics operations, and so as well as we had other people back in the office scrambling to help us put this plan together. So it truly was a team effort.
It's interesting to hear how it goes, because it reminds us that working in space is not as easy as it sometimes looks. You've got to do what to take care of things as they crop up.
Absolutely, and that is one of the other things that I have learned in my 17 years, is that it is important to prepare for the unknown. I have rarely, if ever, encountered the issues that we plan for. However, going through that process of being prepared to deal with things in real time just makes you that much more prepared to handle whichever scenario you may be working.
That does come up. Ian, thanks very much. Enjoyed hearing about this. Ian Mills is one of our robotics officers here in the Mission Control in Houston.